Okay, welcome back. In this video we're going to continue on with the price elasticity of demand. Just a real quick reference, we looked at what it was, what price elasticity of demand was, how we calculate it, then why we use absolute values. We also looked at the total revenue test and the areas of a demand curve, how it's elastic as you go up, inelastic as you go down, and unit elastic in the middle, and total revenue rises and falls. All right. We also looked at the different ways to draw the 5 different graphs. So first we drew a pretty much elastic demand, and that was more flat. Then we drew a relatively inelastic demand that was more vertical. Unit elastic was looked like that. Perfectly elastic was horizontal, and perfectly inelastic was completely vertical. And we talked about how those came about. So what we want to do is look at these determinants of price elasticity of demand, and that is, why is something either an elastic or an inelastic product. All right. So there's 3 of them that we're going to look at primarily, and no, make that 4. The first determinant is the number of close substitutes. All right. So how, if there's a product out there that has a lot of substitutes, if the price rises on it, you're much more likely to switch and go buy another product. And so, if we were looking at the percent change in price, so let's say that, let's see, percent change in price, remember, over percent change in quantity demanded. So let's say that something went up, 20%. If there's a lot of substitutes out there for it, then that means, people are going to switch a lot. Okay, it might be 40% or 50% or 60%, but so that would cause this to be more of an elastic product. What if there was something without close substitutes? Think about something like gasoline. Okay, if the price of gas were to go up, use these numbers. If the price of gas were to go up 20%, what's going to happen to the quantity that we demand? All right, and so since there really aren't any substitutes for gasoline, there's some, you could argue bikes, or you could argue public transportation or walking or stuff like that. But, if you're like many people in the United States, you live in a place that might not be right around the corner from where you work or go to school. So I'll just say that if they raise the price of gasoline 20%, I still got to drive to work. Okay, so if they jack the price up 20%, I may on the weekends try to consolidate trips or something, but I might only buy like 3% less or 4% less in gasoline, and so whatever this number is, it's going to be less than 1, and so that would give you an idea of the number of substitutes. Okay, if there's a lot of substitutes, more inelastic. If there are fewer number of substitutes, it's going to be elastic. So let's look at a couple of examples, and you tell me, well, you won't tell me because obviously I'm not there, but think about what this would be. So what about chicken? Do you think chicken, based on this number of substitutes, is elastic or more inelastic? All right. So hopefully you said that would be elastic, because if you go to the grocery store and there's a 20% increase in the price of chicken, then a lot of people are going to switch and buy pork or beef or something like that, and so this number might be 30% percent change in quantity demanded. How about chemotherapy? What do you think that is? All right, and this would pretty much be inelastic, and you find this with a lot of medicines, prescription medicines specifically, non-generic medicines, or certain types of treatment for disease, and that's because if they jack the price of chemotherapy up by 20%, what are people going to do? All right, so if the price goes up 20%, are you still going to get chemotherapy if you need it? And the answer is hopefully yes. And so maybe we lose 1%, something like that, but the idea is that chemotherapy really doesn't have a close substitute. How about cigarettes? Do you think elastic or inelastic? All right. So if you're a smoker, are there other alternatives for you that would give you the same satisfaction or utility that you get out of smoking? And the answer is probably no. And so we would say that that's more inelastic. How about, we got a lot of C's here. Coffee? Is there a good substitute for coffee? If you know any coffee drinkers, if the coffee went away, it would be very sad because they don't have good substitutes for coffee. Some people can take it or leave it, so depending on the person. But and this gets us into another one when we look at the level of necessity. But so coffee would probably be more inelastic. How about shirts from Old Navy? Okay, it's like t-shirts or shorts or pants or whatever. Would that be inelastic or elastic? And since there are lots and lots of substitutes for Old Navy, we would say that that would be elastic. All right, so this is our first determinant, the number of substitutes that are available. And this is really the big one of them all. Uh, so anyway, I'm going to erase this. So if you're still copying, then pause it. All right. So the second one that we're going to look at is the degree of necessity. Degree of necessity or level of necessity. Necessity. All right, so that's this one. And so let's take gasoline again, for example. Where I live, I have to drive about 12 miles to work. If gasoline went up in price, I would certainly keep buying because I have to get to work. If the price of Cheerios went up, however, I would probably not keep buying Cheerios. I'd probably switch because there are a lot of, well, A, there's a lot of substitutes for Cheerios, and B, Cheerios in and of themselves are not necessities. All right, so gasoline, you'd say because of A, the first one, that there aren't many substitutes, and B, the level of necessity, that's what's going to make this a very inelastic product. What about how about popcorn? Okay, based on the idea of the degree of necessity, we would say that this is definitely elastic. All right. What do you think happens with popcorn when you go to the movie theater? Do you think it becomes more elastic or inelastic versus popcorn that you buy at the grocery store? Okay, and so the popcorn at the movie theater might move towards inelastic, but anyway, so you can see there's different ways to define this. How about what if we traveled back in time for way long ago and gave a computer to a caveman? All right, silly, ridiculous example, but to illustrate a point, you know, what's the level of necessity for caveman to have a computer? All right, obviously, there isn't one, except to throw something, you know, throw it at some food, hopefully, and whack it over the head and kill it. So anyway, so obviously this would be very elastic for the caveman. All right, how about a computer for a college student? All right, now we're getting definitely much more towards an inelastic product because it is hard to be a college student today without having some kind of computer, desktop, laptop, you know, tablet, whatever it is. And so we say that this is much more inelastic because of the level of necessity. All right, what about alcohol? All right, for most people, you know, alcohol isn't a necessity, but what if you're talking about an alcoholic? If they change the price of alcohol and somebody's an alcoholic or a drug addict, you know, we might talk about heroin. If they raise the price of heroin, then same kind of thing. You know, for the addict, that change in price isn't going to matter a whole lot because they want the product because they perceive that there is a either physical or emotional or whatever kind of need for it. So, anyway, so that's what we would look at with degree of necessity. All right. So the next one is time. All right. So to illustrate this, what if I said that gas is $2.50 a gallon? All right. Would we be happy or would we be sad about that? So if we came up today and somebody said we're going to make gas $2.50, we would definitely be happy about that because right now, you know, it's sitting at like $3.45. Now, what if we were, I don't know, 10 years ago? And I'm going to make up a number, and I remember at some point, it was probably 11 years ago or 12, it got to like $1.25. it was very low. All right, it was a little blip that it was that low. But so if we're sitting here at $1.25, and now I say, what if gas is 2.50 a gallon? You'd say you would be very unhappy. All right, and so the idea here is though that over the course of time, the price has gone up, and as time goes by, we adjust our spending uh, to take into account the changes in price. And so if you do any grocery shopping, if you buy something regularly, over the course of time, you might see, this 10% rise in the price. But, after a year, after 1 year, you might still be buying, you might buy the same amount as you did a year before. So initially you might go down, your purchases may go down, but over the course of time, they're going to go back up. And so the price, the amount of time that's been allowed allows you to adjust for your price, allows you to adjust your spending. So anyway, so the longer the time that you give it, the more elastic it becomes. The shorter the time frame, the more inelastic it becomes. So if the price of gas went up to $5 tomorrow, then people would freak out and this would be an inelastic product tomorrow. But what about in 3 years if the price of gas is $5 a gallon? It would probably be more elastic or move towards elasticity, being elastic. All right. The last one that we're going to look at is the proportion of income that's spent on a good. So just a couple quick examples should be able to illustrate this point. So I was grocery shopping this weekend and I had to buy a thing of salt, and I think it was something like 75 cents. All right. So what would happen if I went in to buy salt and instead of having to pay 75 cents, I had to pay $1.50? What do you think I would do? And well, I would still buy it because it's a 75-cent increase in the price. It is a very small proportion of my income. Okay, so when you look at products that are very cheap, so salt would be one. Another example that economists use a lot would be toothpicks. If you go in and they're typically 50 cents each and then they go to $1, are you still going to buy toothpicks? And of course you will. It's only 50 cents. What's 50 cents? So these would be, so when the proportion of your income is low, that means that they are very inelastic. Because if I'm going in, let's remember again the formula here, percent change in the quantity demanded divided by the percent change in the price. If I'm going in to buy toothpicks and there's been a 100% increase in the price of toothpicks, maybe people buy 5% less, something like that, because it's only 50 cents. And so this would be obviously a very small number, which would make it inelastic. All right, now on the flip side, what if we were talking about you're going on a cruise, you enjoyed cruises, and the cruise that you bought was $1,500. All right, now what's going to happen if the price doubles? All right, so now the price goes to $3,000. Does that mean everybody is going to not go on a cruise? Obviously the answer is no, but if we have a 100% increase in the price, would you expect, well, let me back that up. Let's make it a 50%. 100% is not going to work. So 50%, if we had a 50% increase in price, so scratch that, oh my lord. 50% of 1,500, 750, 2,250. All right, quick math on the fly. So if the price goes from 1,500 to 2,250, now you're talking about $750 of your income, which does start to take up a proportion of your income. All right, and so you might actually start to see, people buy 80% less, going 80% fewer cruises. That'd be a negative. All right, and so, whatever this fraction is, 1 point something. So as the proportion of your income goes up, a product becomes much more elastic. All right, let me do one more example. Hopefully I won't have to math too much in it off the top of my head. All right, how about a car? So you're looking at a car, let's say, and the price is $20,000. All right, what if there is a 10% increase in the price of the car. That goes up to $22,000. All right, and so that's a $2,000 change in the price, and so that would be a pretty significant portion of many people's income. And so, if the price went up 10%, we might buy 30% fewer cars, as long as it's a specific car, because we're probably still going to buy a car, and that gets into substitutes. But anyway, so this is what we mean by proportion of income spent on a good. All right, now let's keep going. One of the other things you're going to have to do is to calculate the price elasticity of demand between two designated points on a demand curve using the price elasticity of demand equation that we talked about. So let's say that here's our demand curve. Let me fill this in. Demand and price. And so let's say that we're going from 10 to 8. You need to calculate the value. And so again, it's percent change. I'm going to drill this into your percent change in the quantity demanded divided by the percent change in price. Now, before I get into this too much, there's different ways to calculate price elasticity. This is the way that we're going to use it. There's another thing called arc elasticity, which is a little bit different math, but this is we're going to, again, following the KISS principle. And so to find the percent change in quantity, all you need to do is take and this is this percent error formula. So take the new value minus the old value, and then divide that by the old and multiply it by 100. All right, and so you do that for the percent change of anything. So percent change of quantity demanded, percent change of price. So when we go up here, we would say that the new, if we're moving from 10 down to 8, this is our new. All right, so we're going to take 8 minus 10, so new minus the old, divided by the old, divided by 10, times 100. And that's going to give us the percent change in quantity demanded. All right, so whatever that value is. Then we're going to put that over. All right, because that's just, I'm sorry, I messed that up. That was the price. Shame, shame. Let's see if I can do something. Let's try that. So I just did the percent change in price. So I messed up. It happens. So that's the percent change in price. The quantity, so there we go. So now we want to know the percent change in the quantity demanded. And so we'd say, okay, if we're going from 10 down to 8, our old quantity was 8, our new quantity is 18, and so we're going to say the new is 18, so 18 minus 10 divided by 10 times 100. All right, and that's going to give us the percent change in the quantity demanded. So let me erase a little bit here. So when you do all this math out, 18 minus 10 over 10 times 100, that gives you 125. And this gives you 8 minus 10 gives you negative 20. And so when you do the math there, you end up with 6.25. All right, and so the price elasticity of demand going from 10 down to 8 would be 6.25. All right, so that's how you calculate these. Take a minute and see if you can calculate the price elasticity of demand going from $4 to $2. So pause the video and see if you can work it through, and then when you're done, come back and see how everything went. Okay, so go ahead and pause it now. All right, did you pause it? Hopefully you worked it out. Just don't watch me, because when you have to do it yourself, you might run into problems you hadn't foreseen. So, so here we go. Going from $4 to $2. So again, we want percent change in quantity demanded over the percent change in the price. And so percent change in quantity demanded, we went from 80 to 50. You know what? Use a different color here. We'll go red. So percent change in the quantity demanded, so 80 is our old, 50 is our new, so 50 minus 80 divided by 80, because we're doing new minus the old divided by the old, times 100, over change in price. 4 is the old, 2 is the new, because we're going down. I said what's happening from $4 to $2, so that would be 2 minus 4 divided by 4 times 100. So when you math that out, you end up with 0.125 divided by negative 0.5. And so you should have ended up with an elasticity value of 0.25. All right? And so that's how you look at a chart and calculate the elasticity. And so we know that 0.25, that's an inelastic product, and 6.25, or I'm sorry, that price range is inelastic. 6.25 would be an elastic range for this price. Alrighty, so let's keep on chugging. This is going to be a little bit longer, so I apologize. But now we need to look at why the price elasticity of demand varies along a line. All right, I'm going to flip back to the other one in just a minute. Let me go ahead and do that now. So you can see up here we have an elastic product, and then down here it became inelastic, so elastic to inelastic. So as you go down the demand curve, it goes from being elastic up here to somewhere being inelastic. All right, and you could use the total revenue test to figure out where that point is. It might be there, and so then everything this way is inelastic, everything that way is elastic. But the higher you get, the higher the elasticity value becomes. And conversely, the lower you get on the demand curve, the lower the elasticity value becomes. All right, and so what we want to do is figure out why that is. And when you do that, I want you to think about the determinants of demand. And so as the price goes down for a product, all right, what's happening to the percentage of your income that's being used to buy that product? All right, so as the price goes down, percentage of income goes down as well. And we know that if the percentage of your income is getting smaller, then the product becomes more inelastic. All right. And conversely, as you go up in price, so that means we're going from there up to there. So let's say P1 and P2. As you go up in price, what's happening to the percentage of your income that you're using towards this product? All right. So that's the first one. Also, look at the idea of substitutes. And this is the other reason, substitutes. If the price of your product gets really low, and pretend that it's the lowest of any of the substitutes, then what happens to the number of substitutes available at that low of a price? And so you would say that, you know what if the price of Coca-Cola 20 ounce dropped to 25 cents? All right. Are there a lot of substitutes for this Coca-Cola at that low of a price? And you would say no, all right? And so that would give it a very inelastic range. And so that's why, you know, down here at 25 cents, we would say Coca-Cola would become very inelastic because there aren't many substitutes. But as you go up in price, then what happens to the number of things you're willing to use as a substitute for the product? And so if Coca-Cola started going from 25 cents, then it got up to $1.50, at some point we start to say, you know what, I am going to switch to Pepsi, or I'm going to just drink water, or whatever it is. All right, and so these are the reasons why the elasticity values change from elastic at the top to inelastic at the bottom. All right, it's not just the slope, it's not measuring slope. All right. Now, a couple more. Hang with me. We are only 23 minutes into it. It can't be that bad. All right. I promise I'll be as quick as I can. So examine the role of price elasticity of demand for firms in making business decisions regarding prices. All right. And their effect on total revenue. So remember, we use the total revenue test. This total revenue test. Let me back that up and say, what if you are, again, we'll use Coca-Cola, and let's say that you have a price of $1.50. Should you raise your price or lower your price if your goal is to maximize total revenue? Now, one side note, is it the goal of any business to maximize the total revenue? And intuitively you want to say, yeah, you want to bring in as much money as you can, but actually what you want to do is to maximize total profit, because that's why you are in the business in the first place. But anyway, let's pretend real quick that they want to maximize total revenue. And so if you're Coca-Cola, should you raise your price to say $1.80? Would that raise total revenue? Or should you lower your price to say $1.25? Would that raise revenue? All right. You have no way of knowing unless you know what? All right. Unless you know the elasticity of it. And so let's say the elasticity value of Coca-Cola was 1.5. That's telling you it's an elastic product. All right. And if it's elastic, what's going to happen if elastic? An increase in the price is going to lead to a decrease in the total revenue, and a decrease in the price is going to lead to an increase in the total revenue. So if you're a business, whatever business you own, whatever product you're selling, you want to know what the elasticity value of your product is, because that way you'll be able to say, you know what, we need to generate some more revenue. Let's lower the price. Or if you're the salt company, we want to raise revenue. Let's raise the price of salt. All right. Uh, let's see. Let's look at. Let me ask this question real quick. So let's say that you are the salt producer and you're operating down here, and you're charging 75 cents, and you're in the inelastic range. We could do salt or cigarettes or anything that's very inelastic. And so let's just take salt and let's say it's 75 cents. Why would you not raise your price? All right. So let's say that this is unit elastic, and so anywhere up here is elastic. All right. Why would you not? Why would a salt manufacturer continue to charge an amount that's in the inelastic range? Because we know that if their elasticity value, let's just make it up, is 0.5, then by raising the price, then they can raise total revenue. All right. And it doesn't really necessarily have to do with the profit maximizing. The reason that they're going to stay in this inelastic range, and there's just one word that takes care of it all, and that is competition. All right, because there's other salt producers out there. If they raise their price, everybody's going to buy the other salt. All right, and so if they raise their price to $1.25 and they're the only ones in the industry to do that, then everybody's going to go buy the 75-cent salt. If they could all get together and say, hey, you know what, let's jack our price up to $1.25, then that would make them extremely happy, because if there's not as many substitutes for salt, people are still going to buy it. So anyway, so that's why a company would continue operating in the inelastic range. Now, just so you know, when we get to do monopolies, remember the monopoly. A monopoly is just when one company charges. There's monopoly is one producer in an industry, and so they will never operate in the inelastic range. Now, you should never use the word never, so we'll say mostly never. But hardly ever operate in the inelastic range, and that's because if they're the only producer, then they can jack up the price and they don't have any competition. So anyway, so make sure you understand why a business would want to know the total or the price elasticity of demand of their product. All right, two more, then we're done. All right, so explain why the price elasticity of demand for commodities is relatively low and manufactured goods is relatively high. And so by commodities, we usually mean like the raw materials. All right, and so this might be corn that you grow, or copper that you mine, or coffee that you pick, or any of those things. These are all commodities. All right, now what can we turn this into? How about cream corn? All right, that would be a manufactured product. Actually, let me change this one. We'll just do these two. So coffee beans could be turned into, how about a cafe latte? Not exactly sure who sells that, or if that's how you spell it, or whatever. But and so this would be our commodity over here. All right, so this is the raw product, and this would be the manufactured product. All right, and so why is the elasticity of these very low while the elasticity of these very high? And again, it gets in to the idea that there aren't many substitutes for the raw materials. All right, so if the price of coffee went up, then people are still probably going to buy about the same amount. We know that coffee is inelastic. If the price of corn goes up, ears of corn, then we're still going to buy maybe the same amount, maybe not, maybe a little bit less. But anyway, so what about if you go to the store and you see cream corn is more expensive? Then there's a lot more substitutes for cream corn. I mean, there's tons of cans in the canned good aisle. So lots of substitutes here. Coffee, lots of substitutes for this product, not necessarily just coffee beans itself. All right, so that's why I would say that raw materials have a lower price elasticity of demand, and manufactured materials don't. All right, they have a higher one. Alrighty, almost done. And then I'm going to go back and make one more point. So look at this one real quick. The significance of price elasticity of demand in relation to indirect taxes. All right, so let's look at two products. Let's take cigarettes. All right, let's say that the price of a pack of cigarettes is $4. All right, and then let's look at, so this is cigarettes. Let's look at Frosted Flakes. All right, there's quantity demanded, price. Okay, so cigarettes. What if the government said, you know what, we want to tax cigarettes because we want to generate a lot of tax revenue. If they do that, let's say that we're buying 100 packs now. So let's say that they jack up the price to $6. All right, what's going to happen to the change in the quantity demanded? All right, so let's say that goes to 90. And so if you do this, you're jacking up the price by 50%. So you have an increase in the price of 50%. And what's going to happen to the change in the quantity demanded? It's going to be very low. All right, and the reason this is important is they're going to sell 90 of them. All right, we'll just pretend they're going to sell 90 of them. That's going to raise them a lot of tax revenue. So they raise the price on something, and they pick something like cigarettes or alcohol or gasoline because they know that if they raise the price, people are still going to buy roughly the same amount. Whereas what if they said, you know what, here is the demand curve for Frosted Flakes, and so 100 there, and let's say it's $4 also. What if they raise the price to $6? Then the quantity that's being demanded is going to drop a whole bunch, and so all they're going to have is the tax revenue off of 20 units, 20 boxes of Frosted Flakes, versus up here, by raising the price, people are still buying it. Okay, and so before the government decides to tax, they need to know the elasticity value. So, when you look at what they tax heavily, oil, well, scratch that, gasoline, huge gas tax. They tax cigarettes heavily. They tax alcohol heavily. Any inelastic product is going to be a potential target of a government tax. All right, so the last thing that I want to talk about is when we look at elasticity, it depends on looking at a product. It depends on the scope of how you're defining the product. Because what if I said, let's see, how about Frosted Flakes? What do you think the elasticity of Frosted Flakes would be? All right, so Frosted Flakes probably be pretty high. There's a lot of substitutes. So let's say that the elasticity is 5. All right, what if I redefined it instead of just saying specifically Frosted Flakes? We want to do all cold cereals. All right, and so now, because there's a lot of substitutes here, all right, but now there's fewer substitutes. There's still a lot for breakfast, but so now there's fewer substitutes for cereal, so this might go down to 2. What about, if we do cars versus a Ford Mustang? Which one of these has a higher elasticity? And so hopefully you looked at this and said, well, there aren't as many substitute for cars, and so this is actually probably going to be kind of low. I'm just making these numbers up, so maybe something like 0.8. Whereas a Ford Mustang, if the price of a Ford Mustang goes up, you might just, switch to a Chevrolet or Toyota or whatever you want. And so, the elasticity of the Ford Mustang would be much higher. And so, again, anytime you focus the market more closely on one product versus an industry, let me just say this, product typically will be more elastic the industry that the product's in, if you just do the elasticity value of the industry, will tend towards, we'll just say tend towards inelasticity. All right, so I'm not going to review everything. You can go back. It's already been 35 minutes. So anyway, I hope you got good notes, and we'll see you next time.